Hello everyone, welcome to SquareRoot Central. In this video, we will be looking at the second of the 7 theorems pertaining to real numbers. So as you can see on the screen, theorem 2 of real numbers state that every composite number can be expressed or factorized as product of primes, and this factorization is one unique, well, apart from the order in which the prime factors occur, that is 2 and 3 are unique. If you write 2 multiplied by 3 or 3 multiplied by 2, both are 6. Now this here is the fundamental theorem of arithmetic. Let us begin with, let's say, 4 prime numbers. We'll take a small number and we'll just use our first 4 prime numbers, that is 2, 3, 5 and 7. So let's begin with the number 210. 210 is not a prime number as it has factors other than itself and the number 1. So we have our composite number 210. Now let us begin factorizing 210 and let us see if we can have the theorem proved. So 210 here, the first prime factor is 2. So if we divide 210 by 2, we get the number 105. Now 105 is also not a prime number again. So let us further factorize 105, this time using our prime factors. So let's see if 105 can be factorized using 2. Well, 2 5s are 10, but then again we have a remainder 1. So let's use the number 3, the next prime factor. 105 divided by 3, we would be getting 35. 35 once again is not a prime factor, it's not a prime number, my bad. So let us use the number 2 to divide 35. We will be getting a remainder 1. If we use the prime factor 3, 3 1s are 3, 3 1s are 3, again we'll get a remainder 2. So let's use our prime factor 5 to factorize 35, or to divide 35 for the matter. 5 divided by 35 is the number 7. Now 7 is our prime number. So 7 will either be divided by 7 or the number 1. Now we have 7 as a prime factor. Let's divide 7 by the number 7 and we get the answer as 1. Let us once again go through the fundamental theorem of arithmetic, the actual verbatim of it. For every composite number, our composite number is 210, can be expressed or factorized as a product of primes. And this factorization is unique apart from the order in which the prime factors occur. So we have our composite number 210. This can be expressed as 2 multiplied by 3 multiplied by 5 multiplied by 7. 2, 3, 5 and 7 all are prime numbers. So for all composite numbers, we can express them as a product of primes. This here is the proof for the fundamental theorem of arithmetic. Now let us see if we can use the same concept for another number. Let's do one thing for simplicity. Let's just use the next multiple of, or the next multiple of the number 210. So let us see what happens if we try to factorize the number 420. As you can see on the screen, the rest of the factorizations, well, you've already done those. 210 divided by 2, 105 divided by 3, you get 35. Divide 35 by 5, you get 7. Divide 7 by 7, you get the number 1. Now 210 multiplied by 2 is 420. So you divide 420 once again by the number 2, which is our prime factor, and that's what you get. So you can factorize 420 as you can see on the screen. Now once again, 420 can also be written as 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 7. That is 2 raised to the power 2 multiplied by 3 multiplied by 5 multiplied by 7. So every composite number, 420 is our composite number, can be expressed as or factorized as a product of primes. And here this factorization is unique. There is no other way or any other numbers that can come here which multiplied together will make 420 except for changing the order. So that's it for today's video. We have theorem 3 coming up in our next video. Also check out the previous 2 videos to understand what real numbers are and the first theorem pertaining to real numbers. The link is in the description below. For any other inquiries or questions, do write to us, mention them in the comments, follow us on social media. This is SquareRoot Central signing out.